Hello everyone! Next, we'll explore the process of growing cassava in the hot desert and its journey into many nutritious, health-supporting foods used in everyday life. The process opens in a barren desert where heavy machinery reshapes the terrain into a workable agricultural surface. Sand dunes are leveled, compacted layers are broken by deep plowing, and air is introduced into the soil structure. Organic matter is then delivered and mechanically blended, transforming unstable sand into a moisture-retaining growing medium. The land shifts from raw desert to a prepared foundation capable of supporting cultivation. Once the soil is formed, a controlled water network is established beneath and across the field. Trenches guide the placement of main pipelines, filtration units stabilize water quality, and secondary lines extend across planting rows. Drip systems are calibrated and secured, and when activated, water begins moving precisely toward designated planting zones, creating consistent moisture points across the landscape. Planting material is standardized before entering the field. Selected cassava stems are cut, measured, shaped, and treated to protect against disease and stimulate rooting. After controlled drying, the prepared stakes are transported as uniform biological units ready for structured planting within the irrigated environment. Planting follows the established moisture grid. Stakes are positioned along drip lines, inserted at controlled depth and angle, and stabilized by compacted soil. A thin sand layer is applied to reduce evaporation and maintain moisture stability. Row by row, the desert surface transforms into an organized agricultural layout prepared for synchronized growth. Nutrients are introduced through the irrigation network, merging water and fertilizer into a targeted delivery system. Buds swell, shoots emerge, and root systems expand beneath the surface. Moisture levels and irrigation timing are continuously adjusted, guiding early development and ensuring the young plants adapt to the desert environment. As growth stabilizes, field management maintains uniformity. Missing plants are replaced, weeds are removed, and protective treatments shield developing foliage. Pruning and leaf control redirect energy toward underground development. Gradually, the canopy closes, forming a shaded layer that stabilizes temperature and reduces moisture loss across the field. With structure established above ground, growth intensifies below the surface. Nutrient adjustments support tuber formation, stems strengthen, and periodic inspections track underground expansion. Irrigation lines are maintained to sustain consistent delivery, keeping biological development aligned with environmental control. As maturity approaches, irrigation is reduced to concentrate starch within the tubers. The soil dries and loosens, preparing the field for clean extraction. Final checks confirm readiness, marking the transition from cultivation to harvest. Harvest begins by clearing the upper structure and loosening soil around each plant. Root systems are extracted, tubers are separated and cleaned, and the crop is collected in a steady, continuous workflow. Movement across the field remains systematic, ensuring efficiency from plant to collection point. Collected cassava is transported directly to the processing facility, where agricultural output becomes industrial input. Tubers move through cleaning, washing, inspection, and preparation stages before packaging and storage. The process concludes as the harvest transitions from field production into a controlled supply chain, ready for distribution. industrial journey begins as raw cassava roots enter the plant and move directly onto conveyor systems. Initial washing removes soil and surface impurities, while rotating washers stabilize the material flow. From this point, the raw agricultural input transitions into a controlled processing stream, ready for mechanical treatment inside the factory. The cleaned roots advance into peeling systems where outer skins are separated through steam and mechanical abrasion. Waste skins are diverted, and the exposed white core continues forward. The material is now standardized in surface condition, preparing it for precise size reduction and consistent downstream handling. Peeled cassava moves into cutting lines where it is diced, sliced, and shredded into uniform forms. This transformation from whole roots to controlled fragments ensures stable movement across conveyors and creates the structural foundation for grinding and pulp formation. Reduced cassava pieces are processed through grinding systems, breaking down their structure into fine particles and slurry. With the addition of water and mechanical force, the material shifts from solid fragments into a fluid state, enabling controlled transport through enclosed industrial pipelines and mixing units. The slurry is refined as fibrous residues and wastewater are separated from the starch-rich content. Clean pulp is directed into mixing systems that stabilize consistency and composition. At this stage, the material becomes a standardized intermediate ready for structural consolidation. Hydraulic pressing removes excess liquid and increases density, transforming the pulp into compact, manageable forms. These structured masses improve handling efficiency and prepare the material for moisture reduction and final conversion. The pressed material enters drying systems where controlled heat reduces moisture content. Once stabilized, it is milled into fine cassava flour, marking the transition from semi-processed pulp into a finished food-grade base ingredient. Flour passes through sifting and sensor-based inspection systems that remove coarse particles and verify consistency. Only material that meets defined standards continues forward, ensuring uniform texture and purity before packaging. The refined product is dispensed into bags and containers, sealed, labeled, and transferred through robotic handling systems. Units are stacked, wrapped, and organized, maintaining a continuous and protected industrial flow. Finished products are transported across the facility, loaded into trucks, and distributed to retail and food service channels. From factory output to everyday use, cassava moves from industrial processing into kitchens, markets, and final consumption systems, completing the full production cycle.
quan trình phang lưu âm đã em nhìn ăn thì là cuốn phần nhiệt bình thườngในชาวบนไดนะคะได้ความรู้พันวันดักเลยนะคะ
Hehehehe